Hey, today we're going to use the exponential one-to-one property to solve exponential equations. And so equations are two things that are equal. So if I have two bases that are exactly the same, so I have on this one I have a to the b is equal to a to the c, then then b and c must be equal. So for example, down below, if I had two bases that were the same, x, and I said um, B was 3 and I didn't know what C was, then write C has to be 3 if the two expressions are going to equal each other. So what we're going to do is we're going to look at a couple of examples, and we're going to have to change the basis so that they're equivalent. So the best bet on doing these is looking at the base and then seeing which one it could be changed into the other one, and it's usually the larger number can be changed into the smaller one. So I'm going to write 3 squared for 9 and 3 to the x plus 1. Now I have the same base. I can set the powers equal to each other, and I can solve. And there's my answer. Um, Obviously, with the mental math there, if I plug 1 in for x, I get 1 plus 1 is 2, and we know 3 squared is 9. I encourage you, though, to go through the properties correctly so that you get used to changing your base because they're not all that easy. On this one, I encourage you to write your negative exponents. So notice 1/5 can be written as 5 to the negative 1. Oops. Bring that fraction up, raise to the x, so I get 5 to the negative x. And I can do the same thing here with 25, right? I can write 25 to the negative 1, and then I can get them to get the same base by writing 5 squared to the negative 1, and power raised to a power. Now I have the same base, and I can say negative x is equal to negative 2, negative x is equal to 2. Which again you can do with your mental math. I'm just going through the properties because some of them are more difficult and you can't do with your mental math. Okay, number 3. I'm going to take 3x squared. 9 can be written as 3 again. And then I'm going to set my powers equal to each other, and I'm going to solve. Don't forget a quadratic has solutions. And there's my answer. Number 4, again, I'm going to use the base of 3. And this time it's 3 cubed is 27. Raised to the 2x. Notice that I keep in parentheses the equality there of 3 cubed being 27 and raise it to the same power, and then go ahead and simplify it. Power raised to a power is multiplied, and now I can go ahead and set these equal to each other. I have a trinomial, quadratic, and then I can factor this and solve and get 7 and negative 1. Number 5, I notice all these bases can be converted into 2's. So I have 2 squared instead of 4 times 2 to the x squared. That's already base 2. 16 can be written as 2 to the 4th, and that's squared. Now I'm just going to simplify those powers. 2 to the 2x times 2 to the x squared equals 2 to the 8th. Remember, when you have bases that are multiplied that are the same, you add the power, right? So if I had x squared times x to the 5th, that would be x to the 7th. I would add them up. Same thing here. I'm going to do 2, got that common base, and I have 2x plus x squared. Now I have my one-to-one property, and I can set my powers equal to each other, and I have 2x plus x squared equal to 8. And I'm just going to subtract my 8 over and write this in standard form so I can factor and solve the x plus 4 times x minus 2, and x is equal to -4, we have +2. And then my next section, I have the same base, which is e, which is 2.718, remember, like pi. So I don't have to do anything except for set my powers equal to each other and then solve this. And I have x is equal to -. Okay, so you'll have some practice on these, and I'll see you in class on Thursday, Friday.